Hello 108 students, Mr. McHugh back here with you on page 2. Going to go ahead and keep working on section 9.1, quadratic equations, and going to do a little practical application here. If you happen to be on page 497, 498, we're going to talk about Galileo and his Leaning Tower of Pisa, and he discovered the equation. And when you see these equations, say the words. Don't get all wrapped up with letters because you're never going to remember them. You want to say the distance of a falling object. He had the Leaning Tower of Pisa, and he discovered that if you did not count, this formula doesn't take into account, oh my God, sorry folks, I should have read this thing. Resistance, that's what it was. I couldn't get the right word. Okay, before you say if I drop a bowling ball and I drop a feather, it's not the same times. This equation is not counting resistance. Its distance, the falling distance off the tower, was equal to 16 times the time that it took in seconds squared. So D equals 16t squared. They give you that equation and they go, what happens if you're 180 feet high in the air on the Leaning Tower of Pisa? How many seconds would it take for an object to fall? Okay, so given information, you got your MSI hats on. Distance, 180 feet. Plug it in. And we want to find the time. So we put 180 equals 16t squared. Now, can we isolate the t? T squared. So divide both sides by 16. And you get 11.25 equals t squared. Okay, now what do we do to get isolate the t? You've got to take the square root on both sides, and that drops down to t. Remember, square root undoes squaring, drops the t because t times t is t squared, and you have 11.25, and you need to take the square root of it. We are going to only consider the positive answer of 3.4 seconds because you can't have negative time. Negative time is out the door. It doesn't exist, at least not in our world. I keep watching those history channels and talking about the universe, that and 325 National Channel, and the wormholes and stuff and black holes, kind of crazy stuff. So who knows about time. Okay, but enough of that said. So you get a couple fairly easy warm-up application problems there. Objective 3 is now going to ask you, what if you take a binomial and you square it? Get the words in your set. Don't worry about ax plus b equals quantity squared equals c, a constant. How can you solve for x? Okay, a and b and c are all constant numbers. So the idea here is, how do you undo squaring? That's right, you're going to take the square root on both sides. That's basically what you're going to look at. So what I tried to do up here was, if you were given the equation 4x squared minus 12x plus 9 equals 18. If you were given that and you were asked to solve it, now this is a warm-up set, but I want you to see where this came from, because when I had algebra back in the day, they never explained where this parentheses came from. Well, it's from factoring. Factoring a trinomial, which is a quadratic, and it's a perfect square trinomial, so it's the binomial squared, and I factored it, and you got 2x minus 3 quantity squared equals 18. Now this is where the problem starts, but I want you to know where it came from. Okay, I took 2x minus 3 quantity and I multiplied it out again by FOIL, and it would boomerang back. This FOIL would reduce down to that. Okay, so here we go. What do we do to solve for x? Let's get serious here. I need to break away the parentheses and the squaring. I like to make it all go away, and in one fell swoop the square root on both sides does the job. However, when you do the square root with a number, don't forget it's a plus or a minus can give you 18, and over here the base drops down, so you got 2x minus 3 equals plus or minus 18, square root of 18. Okay, now still our goal is to isolate for x, so I'm going to add 3 to both sides, add 3, and there's where the 3 plus or minus square root of 18 came from. Then I'm still trying to isolate the x, so divide by the coefficient 2, and this time make sure you do, my math lab likes everything under one common denominator, so stick with this form over here. And now you've got x equals 3 plus or minus the square root of 18 divided by 2. Okay, now over here I said these were equivalent. Yeah, but stay away from them because MyMathLab doesn't like it. Okay, now what you're going to find out being a pain here is MyMathLab, it's 3. I like writing plus or minus, but you need to make it 3 plus the square root of 18 divided by 2, comma 3 minus the square root of 18 divided by 2. You see how you have to have 2 solutions there? I wish MyMathLab would get that, plus or minus. It'd make life a little easier. Okay, so just be patient when you put in your 2 separate answers with the comma. Remember, you're giving 2 separate solutions. This is not ordered pairs from graphing. Okay, objective number 4, completing the square technique. Okay, now what we're going to learn here is given, these are kind of some warm-up exercises. So given x squared plus 8x, what would that middle term be to make a perfect square trinomial? Okay, now the shortcut to learn here is to take the middle term, cut it in half, and square it. So listen to my words. Take the middle term coefficient, 8, cut it in half, and square it. 8 divided by 2 is what? 4. 4 squared equals 16. So what we're saying here, instead of a question mark, we're going to put a 16. X squared plus 8x plus 16 would complete the square, and if I asked you to factor it, you would use perfect square trinomial, because you would take the square root of the first term as x, square root of the second term is square root of 16, the third term is 4, bring down the middle sign, and you're going to square it. Again, if you took the quantity x plus 4 times the quantity x plus 4, it would boomerang back the trinomial. Okay, so we're going to do more of that on the next page 3, so get ready to understand more about completing the squares. So help us with solving quadratic equations. Okay, Mr. McHugh, going to say goodbye for now. We're done with page 2, and I'll see you on page 3. Okay, take care.